Hi guys, my name is Stefano Bernardini and today I'll show you how to use MuleSoft with Apache Kafka. Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical application. With MuleSoft, we can use the Kafka connector. Okay, let's set up a Kafka installation. We can either install with Docker, thanks to the bitnami image, or we can also use the confluent.cloud version. Okay, so let's go to the bitnami Kafka version. We can just go to an empty directory. Then we can create the Kafka Docker Compose YAML image. Okay. We can create a file with the name Docker Compose YAML. We can just cut and paste the example. Okay. Okay. Cut and paste. Then we just execute the following command. Okay. And I think Docker will do all the rest. Okay. In Docker Desktop we can find if it works. Okay. Okay, so let's go to MuleSoft in order to understand if everything is correct. So let's go to MuleSoft. Let's open a new project. My sys Kafka. Okay. Okay, let's create a global configuration. Okay, let's import the Kafka connector. Okay. Let's see if everything is okay. First, we create the Kafka producer configuration. Okay. So let's add our server that is on localhost on port 1992. Okay. Let's see if everything is correct. Okay. Okay. So this is the simple flow. The producer will publish the message to the topic. Then the consumer pull the message from this topic with the connector message listener. Okay. So let's go back to MuleSoft. Let's create an HTTP listener. Okay, path is not important, /k. Okay. I will insert a publish. Okay. Maybe I can set a set variable in order to save some information I will send. So for example, a UID. UID. Okay, perfect. I can send, for example, I don't know, an application JSON with a message. Hi. and ID. Okay. Then maybe I answer back to the client with I don't know, okay, and the ID, okay, and we'll also put a log. Okay, so we can answer for insert, for example, application JSON, where after the publish id vars id when now. Okay, so we insert also the message listener. Okay, I forgot to insert the topic. For example, we can choose the topic 1. Okay, I have to insert also a consumer Kafka configuration between because consumer and producer use 2 different configuration. Let's put in the same file. Okay, so I need a consumer. Okay, the server is here, and the topic is the same, so topic 1. Okay, let's test the connection. Okay, okay, we can insert the logger. Let's cut and paste this one. So this is after the listener. Instead of ID, I insert the body, that is the payload. Maybe I have to put a transform message because the payload is in binary format. So I insert this read payload application JSON. Okay, let's see if everything is okay. The project is restarting. Okay, it's ready. The URL it's 81/k, I think. Okay, this is my ID. Okay, after the publish, after the listener. Perfect. Let's try if everything is okay. After the publish, CB, after the listener. Okay, this is the simple scenario. Let's repeat. The producers publish a method with the publish connector, the publish activity connector to a topic. Then the consumer pull this message from the topic with the message listener. Okay. Now let's refactor everything in order to use the Confluent.cloud version. Okay, I already registered. Okay, we are inside the Confluent.cloud. We can create a topic. For example, topic 2 with 2 partition. At the moment, it's not important the number of partition. It will be important in the future use case, but not at the moment. So we can just create a topic 2 with 2 partition. Okay. Now we have to refactor in order to connect to this Kafka. So let's do some refactor. Let's create an application properties prop.yaml. Let's put, for example, Kafka URL user pass topic, for example. Okay. At the moment, this is my local configuration. I have no password, and my topic it's topic number 1. I create a configuration property. At the moment, is not important for this video to use secure configuration. It's just a demonstration demo about Kafka, but you can use secure properties in order to give better security to this to your environment variable. So let's select prop.yaml. Okay, let's modify this. Okay, so maybe I can stop. It's better if I stop. Okay, so Kafka.url. Okay. Kafka.url. Okay. Okay, I forgot the topic that is here. Okay. Topic 1. Okay, perfect. The cluster configuration. Let's take the cluster configuration. For example, I create a class Kafka cluster API key. This is my user and password. User, password. Okay. Okay, this is my Bootstrap server. Okay. SSL, and the mechanism is plain, so I can just configure both in the producer and in the consumer the SSL plain. Okay, I have to insert Kafka user and Kafka pass. Okay, I have to insert the Bootstrap server rule, that is Kafka URL. Okay, an additional very important configuration is in the security tab. you have to insert the TLS configuration. For the purpose of this video, I can also set up this flag insecure. Okay. At the moment, it's not important to create all this stuff for the purpose of my video. Okay. But it's important to, if you don't select any TLS configuration, it's important to check as insecure in order to use the SSL. Okay. So let's check if everything is okay. Okay, perfect. Now I am connected to the server. Okay, let's do the same for the consumer. Okay, I select SSL plane, edit inline. Okay, Kafka URL, Kafka user, Kafka pass. Okay, the topic, Kafka topic. Okay, let's see if also the consumer it's okay. No, I forgot. Sorry, I forgot to select the security. So I have to select edit inline and then insecure. Okay, otherwise it will not work. Okay, so let's test connection. Okay, fine. Kafka topic. Let me think. Let me see if everything is okay. No, the topic, my topic is not the topic 1. It's topic 2. Okay. Let's see if everything is okay also in the Confluent Cloud version. Okay. So the scenario is the same. The producer will publish a message to the topic and the consumer pull the message from the topic. But now this Kafka is not on my computer, but it is in the cloud. Okay. And we also see some different configuration stuff about this part. The connection part that may be very a little bit tricky. Okay. So now we are ready. Let's see if everything is okay. Okay. A no topic or partition. There is some problem. A no topic 1. They try to send message, to publish message to topic 1. And there is no topic 1 on the server. In my localhost computer, there is no problem if there aren't any topic, because they create the topic if there aren't. While in the Confluent Cloud configuration, if there aren't any topic 1, they receive an error. So I have to modify my producer configuration. No, not here, but here. So I have to publish not topic 1, but Kafka, we use the property. Okay. So this variable, this value get from there, and topic 2, it's okay. Okay. Let's see if everything is okay. Let's wait a bit. Okay. I think we are ready. Okay. So let's call my flow. Okay. Chewy. So I publish the message and I receive the message. Let's do again. I publish the message, I receive the message. Okay. So the simple flow, it's okay. Let's try with the competing consumer patterns. Okay. In this scenario, the producer send a message to the topic, and consumer, I have to create two consumer A and consumer B, that compete for the message, and only one consumer will receive the message. So only one consumer will pull from the topic. In order to achieve this competing consumer pattern, we have to use the consumer group. Okay, so both consumer A and consumer B will be part of the same consumer group. Let's do. Okay. I create another message listener. Okay. Maybe I can also copy and paste with XML. Okay, I just copy this flow. I create another flow. I modify the name. Okay, it's simple. Okay, transform. Maybe I set a different log in order to understand if it's the first one or the second one. After the listener, this is the name, the number 2, and this is the number 1. Okay. Okay, Apache Kafka configuration. Okay, they use the same. Let's configure it and give the same group ID. For example, group alpha. Okay. Okay. So they both listen from the same topic, and they both be part of the same. They both are a part of the same consumer group. Okay. Let's see if everything is okay. It restarts. Okay. I call it. Okay, listener 1, listener 1, listener 2, listener 2, listener 1, listener 2, listener 1. Okay, as you can see, every time I send a message, only one listener, for example, now listener 1, only one listener will will win the competition for the message. So now the listener 2, now the listener 1. Okay, so the pattern, it's okay. Let's go to the broadcasting. So in this scenario, producer send a message to the topic, and I want that both the consumer get the same message. Maybe I want to do different thing. Consumer B and consumer A must do different things. So it's important that both of them, all of them, receive the same message. Okay, it's a different scenario. It's the broadcasting scenario. Okay, so let's go back to the studio. In this scenario, to achieve this scenario, it's very important that the consumer B and consumer A must not be part of the same group. Okay, so we have to differentiate the two group. In order to achieve this, I have to create another Kafka, another Kafka consumer. Okay, I can, for example, change name. So this is consumer A, for example, and I create also a consumer B. Maybe I can also copy and paste. So this is consumer A. Okay, cut and paste, and I create a consumer B. Okay, it's easy. The group ID is not alpha. I want to use consumer beta. Okay. Now I modify the same flow. Okay. So this is hey. I can say hey. Stop. And this is consumer B. Okay. In order to achieve this, I have to modify the consumer group. So now the method listener 2, method listener B, I have to change the configuration. Okay. So producer send the message to the topic. Both the consumer A and consumer B pull from the same topic because they are in different consumer group, and every consumer must receive the same message. Okay. Let's try if everything is okay. Okay, we are ready. I send the message. As you can see, I send a message, I publish a message, and I see to receive A and B, he and B. Okay, so every time I send a message in this broadcasting scenario, every consumer gets its own copy of the message. Every consumer pull its own copy of the message. Okay, every time. Okay. So in this video you learn how to use Apache Kafka with MuleSoft. That's all for now. See you in the next video.